This video shows how to evaluate integrals containing square roots by using algebraic manipulation and substitution techniques. We'll rationalize the integrand by multiplying numerator and denominator inside the square root by x minus 1. This gives us x minus 1 over the square root of x squared minus 1. Then we split into two standard integrals and evaluate each one. Let's work through it on the diagram. How do you integrate the square root of a fraction like x minus 1 over x plus 1? It looks messy, but a clever rationalization turns it into something very manageable. Many students try substitution right away and get stuck. The key insight is to multiply inside the root by x minus 1 over x minus 1, which creates a perfect square in the numerator. Question: evaluate the integral of the square root of x minus 1 over x plus 1 dx. Step 1. We rationalize by multiplying inside the root by x minus 1 over x minus 1. Multiply numerator and denominator inside the root by x minus 1. The numerator becomes x minus 1 squared. The denominator becomes x squared minus 1, a difference of squares. Since x minus 1 squared under the root gives x minus 1, we get x minus 1 over the square root of x squared minus 1. Now let's split this fraction into two simpler integrals. Step 2. We split the fraction x minus 1 over the square root of x squared minus 1 into two separate terms. We write x minus 1 as x minus 1, and split integral of x over the square root of x squared minus 1 minus integral of 1 over the square root of x squared minus 1. Call the first integral I1. We'll use u substitution with u equals x squared minus 1. Call the second integral I2. This is a standard form that equals the natural log of x plus the square root of x squared minus 1. Let's evaluate each integral now. Step 3. For I1, let u equal x squared minus 1. So du equals 2x dx. For I2, we use the standard logarithmic form. For I1, set u equals x squared minus 1. Then du equals 2x dx, so x dx equals 1/2 du. This becomes 1/2 times the integral of u to the negative 1/2, which gives the square root of x squared minus 1. I2 is a standard integral. It equals the natural log of the absolute value of x plus the square root of x squared minus 1. Combining, the final answer is the square root of x squared minus 1 minus the natural log of the absolute value of x plus the square root of x squared minus 1 plus c. Now you can handle integrals with square roots of fractions by rationalizing the integrand. Multiply inside the root to clear the fraction, split into simpler terms, then apply substitution and standard forms. The result is the square root of x squared minus 1 minus the natural log of x plus the square root of x squared minus 1 plus c. A clean answer from a messy-looking integral.